Okay, it is the last rule, and this is what you do when you divide things that have the same bases. So again, we're going to write it all out and hopefully be able to generalize a rule by the end of it. So 2 to the 8th, lots and lots of 2's. 2 times 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 2. 8 2's on the top and 3 2's on the bottom. Now you guys learned way a long time ago that if the same thing appears on the top and the bottom in a multiplication fraction, you can cancel. Because 2 divided by 2 is the same as 1, and multiplying something by 1 does not change the value. So we can cross those off. We are left with 2 to the 5th power. Why don't you try the next two? Go ahead, pause the video, try the next 2 rows, and then come back when you're ready to continue. So once you've done it, you should end up with 5 times 5 times 5 times 5, 3 more 5's, all over 5 5's. And again, we can cancel things out that are equivalent to 1. So 5 over 5 goes away, and we are left with 5 to the 2nd power, or 5 squared. It works the same with variables. 8 x's on top, 2 x's on the bottom. They're going to cancel, and you're left with x to the 6th. Now when there's coefficients, it's just a regular fraction. So this is really 9 m over 3m. We're going to treat each section separately. 9 divided by 3 is the same as 3. 3 over 1 if you want to write it that way. These cancel. So it's 3m squared over 1, or just 3m squared. So we just divide the coefficients like a normal fraction. You're simplifying or reducing your fraction. So the first thing you should ask is, what is 12 over 2 simplified? And then you take care of your variables. So why don't you try this one, and then see if you can see if you can come up with a generalized rule for a division problem. Go ahead, pause the video, and then come back when you're ready to go on. So this would be 12, holy moly, that's a lot of y's. 5, 6, 7, 8, 9, 10, 11, 12, all over 2y. The y is going to cancel. 12 over 2 is the same as 6, and I'm left with 11 y's. So hopefully you guys have seen that the rule is we're subtracting the exponents. So this would become x to the a minus b. And the generalized rule would be divide the coefficients and subtract the exponents. And again, this only works if the base is the same. You can only divide m's by m's and y's by y's, but we'll get to that next class. So the bottom part of your paper is a whole bunch of practice problems. And what I would really strongly suggest is that you pause the video and you take the time to attempt these, and then when you're ready to check, come back and look at the answers. But this isn't going to give you any value if you don't actually try them on your own first. Okay, so for example number 1 here, we have the same base, they're all a's, and we're multiplying them. So when you multiply exponential expressions, you add the exponent. And remember that if something doesn't have an exponent, it's like a ghost 1. It has that exponent of 1 up there. So this is a times a times a times a times a times a. So we end up with a to the 6th power. We add all those exponents. If it helps you to write out the whole expression, by all means, go ahead and do that. For the second one, again, it's a multiply problem. We're going to add the exponents of the variables with the same base. So first we multiply the coefficients. 2 times 4 is 8. A squared times a to the first. We're going to add 2 plus 1 and get a cubed. B to the first times b squared is b cubed. The third one is also a multiplication problem. So we multiply the coefficients. This one's negative. So 6 times negative 3 gives me negative 18. X squared times x to the fifth. I add those together and get x to the 7th. The last one looks very similar to the first one. 3 plus 4 plus this invisible 1 gives me b to the 8th power. In row 2, we are raising things to a power. So remember, this exponent gets multiplied by all the other exponents in the expression. If there is no exponent, it's a 1. So we end up with negative 2 squared and x to the 4th squared. So negative 2 squared is 4. X to the 4th squared is x to the 8th. Same thing here. This exponent gets multiplied by every other exponent. It kind of feels like the distributive property. This would become x to the 4th, y to the 6th. This exponent goes towards everything else. So this is 5 cubed. X squared cubed becomes x to the 6th. Y to the 4th cubed is y to the 12th because we are multiplying exponents. 5 cubed you can put in your calculator or you can use your brain and know that that is 125. So if you want to write it out, that is totally fine. For now, if you want to leave it like 5 cubed, that's okay too. For 8, we are again distributing this exponent towards everything inside. So we get 3 cubed, x to the 12th, y to the 18th. Or if you want to write it all the way out, 27 x to the 12th, y to the 18th. In the bottom row is the division. So remember, we are subtracting exponents. X to the 5th over x to the 3rd leaves us with x squared. If we do have a coefficient, we are going to divide the coefficient. 18 divided by negative 3. 18 divided by negative 3 will give you negative 6. C cubed over c squared. If you vision it all written out, you would have 2 of those c's cancel, and you'd be left with 1 c. If you want to write c to the first, that's fine too. Number 11, I'm going to cancel or simplify the coefficients. So 42 over 2 would give me 21. M cubed over m, because I can only cancel when they have the same base, will give me m squared. And n squared over n is just plain n. The last one is a little bit tricky because 3 over 21 simplifies to be 1/7. Now when I take care of the x's, x to the 7th over x leaves me with x to the 6th in the top. So this is really the same as x to the 6th over 7. All right, so that is exponents. Please make sure that you bring this completed sheet to class so that we can check that you did watch this video and hopefully learn something from it. And if you're still a little bit confused, don't worry, we will be reviewing in class the next few days. We're gonna do exponents all the way up through spring break. All right, enjoy your afternoon.